Okay, so coordinate geometry, year 9 coordinate geometry. Okay, really, to be honest with you, not a hard kind of topic, this one. I mean, most students that I've had found this topic really easy. The only problem with this topic is the fact that you've got to memorize a lot of formulas. Okay, so if you like to memorize formulas and you like to just plug in numbers into formulas, then this is going to be your topic. If you're a person that doesn't like big formulas, well, then this is probably not going to be your topic. So we'll find out what you really reckon. So the first thing I'm going to do for you here is write like a little formula sheet. Write out all the formulas that we're going to do, and then I'll show you how each one's going to apply. So the very first thing we're going to deal with is our axes. We got this is our x-axis, and this is the y-axis. We know these are always going to be our positive numbers. These are going to be our positive numbers as well for the y. These are going to be our negative numbers, and these are going to be our negative numbers for the y. So these are all our x's, these are all our y's. Cool? So if I pick the point here, for example, that could be 2 there, and then 1 there. And the way you would write it is 2, 1. And the reason why that is because that's x and that's y. X is before y in the alphabet, so we write x before y in our coordinates as well. All good? Okay. Then we have something called the distance formula. Okay, so we've got the distance formula. Distance formula comes from Pythagoras' theorem. Note how Pythagoras' theorem is c squared equals to a squared plus b squared, right? And then when you want to actually find c, remember you had to square root it? So it would look something like that. This actually looks exactly the same, except a was distance before. Now you don't have the distance, you only have the coordinate. That's the whole point of this topic, right? So to work out a coordinate, again, imagine that's a point there. That's my A, let's just say, and that's my point B, right? To work out the vertical distance between them, or the horizontal distance between them, I could do something like this. So let's pick another color. Let's go, the vertical distance is this. It's all of this, right? Take away this. If I do that, can you see what I'm left with is this bit in here? Can you see that? So one more time. If I go all of this, take away this little bit in there, so all of A, take away all of B, gets me what's left in between of A and B. And same thing as this. If I go this way for the x-axis, if I go all of A, take away all of B, I'm left with that little bit in there for A and B. Make sense? And that's actually the concept between all this whole topic. If you can just understand that you've got to take away distances to get what's in the middle, then this topic shouldn't be too hard. Because like I said, I don't usually memorize my formulas. I show you where they come from. So if you remember with Pythagoras' theorem, well, this is our distance formula. Ready? Okay. Looks really long, like I said, but don't worry. x1 minus x2 all squared plus y1 minus y2 all squared. Okay, let me show you where they're linked. See, squared here, squared here, squared here, squared here, plus. So the A is your x1 minus x2, and your B is your y1 minus y2. That's it. And that makes sense because I just told you, B, you had a distance before. Pythagoras' theorem, right? You actually had A and B. Here, I'm telling you it's in midair. To work out that distance, you have to go this whole green part, take away the blue part. Cool? Well, okay, now that we've got this distance formula, imagine I gave you a point. Let's just say A is 2, 3, and then B is minus 4, and let's just say 5. Cool? 2, 3, minus 4, and 5. Well, according to my distance formula, I know that D, the distance between these 2 points, must be square root. Alright, now where is x1 and x2? A lot of people mistake that part up as well. Alright, so remember me telling you x is before y. This is x1. This is not x2. A lot of people like to take the easy way out, x1, x2. y1, y2. No, that's incorrect. x1, y1, x2, y2. And if you want to understand what y1 and x2 and all that, these 1s and 2s are, it's just telling us x1, y1 is the first point. 1, the first point. 2 is the second point. You get that? So you're going to take the first point, take away the second point, for example. Or the first point, take away the second point for the y's. Now, a question that arises, does it matter if I wrote x2, take away x1? No, it actually doesn't matter as long as this one's going to be y2 minus y1, for example, as well. Cool? So it doesn't really matter as long as it's x2 minus x1 and y2 minus y1. All right? Or x1 minus x2, y1 minus y2. Cool? So which one you're going to take away first doesn't really matter, as long as you know it's the x's. So don't do 3 take away 2. You know, it could be minus 4 take away 2 or 2 take away 4. All right? And that's what we're going to do. We're going to do that one first. So it's going to be 2 x1 minus x2, which is minus 4. Right? And we're going to square that. Plus y1, which is 3. Right? 3. And we're going to take away what? Y2, which is, exactly, you got the hang of it. Alright, all squared. And then you just got to simplify that. Leave the square root for a second. Just leave the square root. 2 take away 4. Well, that becomes plus. 2 plus 4 is 6. So that's just 6 squared plus. 3 take away 5 is minus 2. But that's minus 2 all squared. So please be careful with that. In your calculator, do not put this. If you write this in your calculator will give you minus 4. Whereas this is what we want. That gives you 4. So please be careful. Okay? You understand the difference? Your calculator does the 2 squared first, which is 4, puts a negative in front. Whereas here, your calculator will do the whole negative 2 and then square it. Alrighty. So that simplifies to 36, which is 6 squared, plus 2 squared, I just told you, is 4. 36 plus 4 is square root of 40. Make sense?